Okay, we are recording. Hello there, everybody. Thank you very much for coming to join us. My name is Jeff Hendrickson. I'll be your facilitator today. I am a design thinking coach, mentor and facilitator. I've taught design thinking all around the world to some of the major corporations everywhere in every single industry that you can think of. We'll be joined today by Dr. Rado Kotorov, by Yoshiko Akai, and by George Poli, all members of this group here within Trendalyze, and I'll have them introduce themselves one at a time too. So Rado, if you would go ahead and introduce yourself.
Thank you, Jeff, and thank you everybody for attending. Rado Kotorov, I'm a co-founder and CEO of Trendalyze. I have my scientific background is in decision theory, which deals with the problems about how people use technology and in general make decisions. And I have 20 plus years of experience in the business intelligence and analytics space. I've been through the entire evolution of the business intelligence and have seen from the emergence of 4GL technologies up to in-memory computing and data visualization. And similarly, I've been through the AI evolution and seen the high and lows of AIs before and now. And so what we've adopted and what we've learned through this is a pragmatic approach where we are building technologies that try to solve problems that are pertinent today and solve them in a pragmatic way, but also doing an advanced R&D to solve the biggest challenges coming in the future.
Cool. Yoshi. Thank you, Rado. And we'll be circling back to Rado again because he'll be doing our demo for us. Yoshiko, could you please introduce yourself?
Hi, I'm Yoshiko Akai. I am Chief Product Officer at Trendalyze. I am managing the product development and data science and data engineering teams. I have a background in product management and project management. I have been delivering enterprise advanced analytics solutions and products all over the world.
Cool, thank you. And George.
Yep. Good morning. Name is George Poli. I'm Chief Operating Officer, primarily focusing on commercialization. Have a long history working in software companies as well as professional services organizations, and lead all of our discussions with consulting partners as well.
Cool. Thank you very much. And just another quick little note, Rado and George and I have all worked together at a previous company too. So we're really happy to be working together on this and presenting this to you. So now I'm going to turn this over to Rado. He is going to do a short deck, and then he will give you a demo on a couple of different data sets, and you can see the power of this tool and start getting some ideas about how this might work for you. Okay, so Mr. Kotorov, Dr. Kotorov, I'm sorry, please take it away.
Thank you, Jeff. I really appreciate it. And thank you everyone for attending. I would go through a short presentation in which I want to explain why patterns in time series data are so important and so valuable in the new digital economy. And let me start with a little introduction about what has changed in time series data and what's so important in it, because time series data has been around with us for decades, but it has changed significantly and it has increased its value and importance in the enterprise. So we start with an analogy. The machine in the human body is the heart that keeps us going. And you're all familiar with the ECG devices that take the pulse and measure the movements and the heartbeats in the heart. And so what has changed in general in the industry today is that we're installing sensors and devices that collect the heartbeats of everything, whether these are engines, processes, or operations. We collect data on that. And knowing the good and the bad heartbeats is really very important and very valuable, because if we can distinguish them and if we can monitor for them in real time, we can actually save or make money or prevent significant events. And so let me move now and explain what physically has changed in the collection of time series data. If I show you this time series, which is collected on a seconds interval, it looks very generic and very few people can even guess what it is. I mean, it's completely doesn't have anything significant in it to identify. But if we switch the granularity to milliseconds, collecting 360 data points per second, we're starting to see very distinct shapes. And 90% of the people correctly can identify this time series as the human heartbeat. And what I wanted to point here is that you move to a particular level of granularity, time series become meaningful. We can recognize them and we can know how we can use those time series by their shapes. And if we go a step further and we start distinguishing the good from the bad heartbeats, like here, we're distinguishing the yellow from the red heartbeats. The yellow heartbeats are pathological conditions such as stroke or a heart attack. And once we start distinguishing them, we know now for sure which are the good and which are the bad and which are the precursors of bad things happening. And we can start using this information to monitor and to build more advanced predictive systems to detect events of significance. And the key point here is when we get in this level of granularity is that we're not only detecting markers of particular events and signals of these events, but we're also detecting causal relationships between markers and events that follow after the markers. And that's what makes time series data so reliable in generating predictions. I want to say that this type of activity is now available in all industries. Everybody is collecting and generates loads of granular time series data. In industrial equipment monitoring and in manufacturing, we have vibration sensors that very reliably help us identify when a potential failure of a machine would happen. In high frequency trading, almost all trades nowadays are being executed by machines that algorithmically detect heartbeats and trigger signals whether it should be a short or a long trade. In vehicle operations, we have installed CAN loggers in the cars and over 250 sensors in the engines that really allow us to do very granular engine diagnostic. But not only that, but also the ability to fingerprint the driver and do forensic after crash accidents. For example, a high speed with a sudden change of the angle of the wheel captured by the sensor reveal precisely who is at fault during an accident. In healthcare, digital health is becoming popular, being enabled by devices that collect the heartbeats of everything. And there are now remote patient monitoring devices for everything: diabetes, blood pressure, ECG, and etc. And it reduces the stays in hospital, and it does also a very significant prevention that saves lives regularly. In retail transactions, you also have granular data that allows you by minute and even seconds in some cases to detect changes in trends. And I want to point here that Amazon becomes so big because they were able to detect patterns and trends in the long tail of retailing, in those items that do not have huge volumes, but for which, if you detected a change of trend in one market, you could promote quickly the item in a different market and double the revenue from such items. In data traffic, probably the most wide applications of granular time series data is the use actually of the use of time series data and pattern detection for intrusion detection. It turns out that the signals often collected at nanoseconds, 9 digits after the seconds, reveal the very essential signature of a particular intended intrusion in a system. I also want to emphasize here that this is the realization of how valuable this data is, coupled with the huge data collection of it, is fastly driving the market. So we know the benefits of the business intelligence market. Once companies started collecting business data, we got the emergence of ERP system to collect more detailed customer data, more detailed sales data, and etc. and it grew up into a multi-billion-dollar industry. The analysis of this data saved companies millions and billions of dollars. And if we look, analytics correlates very closely with the accumulation of data. So in this case now, we have a 10 times faster growth of time series data compared to any other data, which allows some analysts to estimate that this market is going to be growing at 3 times the rate of the business intelligence market. And I want to point that the types of tools that emerge for analysis of different kinds of data are always different. What we do in Trendalyze to enable the analysis of these time series data sets is 3 things. The ability to mine the data sets and find domain experts to be able to find interesting patterns, because it's very important this work to be done by domain experts, because they're the only ones who can give meaning to a pattern. A machine can point you to an interesting pattern, but the machine can never provide an explanation about what this pattern is. So we've combined the human intelligence with the machine intelligence to facilitate the mining of those patterns. We also, at the core of our technology, is a motif search, or the ability to search for similar patterns or recurring patterns in the system, which is very important because recurring patterns typically point to things that we can improve and we can monetize. Recurring patterns also point to the causes of things that systematically occur over time. And finally, what we do is the motif intelligence, where we configure cataloging libraries meaningful patterns, and then we can configure them jointly into systems into artificial logical networks for prediction and real-time monitoring. How is our approach different? We're asked this question very much because there's a lot of discussions about machine learning, deep learning, and in general, the machine learning space has a lot of different ways of doing things. And nowadays, mostly machine learning is associated with statistical machine learning and neural networks, also sometimes called as deep learning networks. And very recently, it was identified, an article in MIT Technology Review, the Google engineers admitted a major problem with the neural networks that we have to be aware. That's not to say they should not be used, but we should be aware of some of the risks. And that problem has been that even when we train models, we achieve high accuracy on the training, but we cannot say if it will work in the real world. Now think about it. Would you go into an airplane, that's self-flying airplane, if you know that the system there is even a slightest probability that something may go wrong and it may misfire the prediction of something? A lot of it is written about that risk, and we are focusing research how to mitigate that risk. Following that, there are surveys by MIT Sloan that says that only 10% of the companies, because of that problem, reap ROI on statistical machine learning. And Gartner points out that 95% of the machine learning projects fail. So what we tried to do in our research is we tried to put the human in the loop, and that's what we did, and create a more human-like learning. That's why we faced on the recognition in the data of the shapes and having the human assign the meaning of the shapes. And what's distinct about human learning versus machine learning is that a human can recognize 2 different shapes immediately. I need to show you only once a wine glass and a teacup and explain to you the differences, and you would know it. I don't need to feed you with thousands of examples how to do that. And that way of learning is very reliable and very fast. And so by using the machines to identify interesting shapes and using the humans to give meaning to these shapes, we are in a position to deliver faster time to market learning, as well as more reliable identification of the things that are going on in processes. Finally, I want to say that the market is evolving and the analysts have recognized the importance of time series intelligence as a separate category from the business intelligence and from the traditional statistical machine learning. And we're very happy to be in a good company with notable companies out there in this category, being the number 2 after Microsoft, and being the number 1 actually for ease of use, listed as the number 1. And I would like to say and point that this market is particularly interesting because of the big differentiation between the clients. And it used to be like that 15 years ago, where every BI company had a specialty and was different. But as the market got saturated, the differences disappear. So we're fortunate to be in a market where the differences and the differentiation is still huge, and we're all trying to push the limit of how we can analyze and understand the language of machines by leveraging time series data. As I said, we conduct a lot of R&D and get grants so that we can move into the future and solve some of the challenging problems that I mentioned. You can see this research on our website. And we also publish books on for management on how you can leverage the data and the analytics to be more competitive and to monetize various assets in the organization. You can look at this, you can send us an email, and we'll send you the right articles and the right research if you're interested. And with this, I'll hand it back to Jeff. I want to say is that we are offering with Jeff a 1-hour design thinking session on how you can build a high-value time series application, monitoring and predictive application. And after Jeff, we're going to move towards a short demo.
Yeah, thanks, Rado. That was great. So yes, on this 1-hour design thinking, of course, right now that has to be virtual. We can facilitate these through Miro. Essentially what you do is just reach out to us and say, I'm interested in that. Let's figure it out. We know that sometimes, and we've seen this a little bit as we're walking companies through this, where they say, it sounds really, really cool, but I'm not sure what to do. So we do a design thinking session like this, and now things become clear, and everybody starts to understand how they can use this and start moving things through, okay? So Rado is now going to start on a great demo, and what I'd like for you to do is open your chat box, open your chat window, and if you have any questions, please start typing those questions in the chat. When Rado finishes with the demo, I'll start reading through these, and we'll hit these as much as we can. We're also going to give you our email addresses at the very end, so that if there's anything you want from us, we can send those to you. Okay, so back over to Rado for the demo.
Yeah, thank you, Jeff. So this is our platform. It is what you're seeing here is the cloud-based version of it, but it can be installed also on premise. And it has various modules from data access, metadata, self-service workbenches, libraries, and dashboards. But I'm going to focus on the self-service workbench and show you the 3 core functions that make the technology, starting with a motif search and finding similar patterns using a motif search, using correlated searches, which are very important within multidimensional space, and going to really a large-scale search in a highly dimensional data. So let me open here a data set that comes from turbofans, and that data set is on minutes, and what you see in the user interface is a standard workbench looking very much like Excel or Power BI, but specifically tailored the design to time series data. And because time series data is very huge, we have 2 sections. One is what you currently see on the screen, and underneath is a navigation that shows you how much of the current data available in your data set can be displayed on the screen. There are limitations on what different screens can display. Some can display 5,000 points, some can display 500,000 points. So we accommodate all of this. And in this case, this is engine data. So let me go, it has several, let me focus on one engine here, type, and we'll focus on one engine type, and we'll show all the engines on the screen. So what you're seeing now is right here, 100 time series. That means 1 time series per engine. So we have 100 units of engines within this type of engine. And let's show all of them on the screen. We can't fit them. We're fitting only this small portion. And you can see this kind of compressed time series of engines starting and ending. And next, I'm going to open from the library a motif of normal operations. So very often a test engineer or a reliability engineer, they know what a normal operation is, and they want to start exploring the data and look for this, look what differs from this normal pattern. So I'm going to configure a matching algorithm here. There are a few parameters that are taken off, and I'm going to search within each of the 100 engines that are displayed, and I'm going to look for a worse match. Is there something in this engine that's drastically different from what you are seeing and what you have as a matching operation? And that's a very simple way of us going through, again, large data sets and discovering those that differ. Oops, I had to change one more thing. I want to look not from the top 9, but I want to look through all of the 100. And let me rerun the search. So that's going to execute 100 queries looking through every data and every point in this data set. And what you see here is what we've returned. So let me zoom a little bit on it. And you're seeing at the end that it's identifying the very differences of this from this pattern when the operations actually in real life dropped significantly down. So if we look here, it dropped significantly, a very sharp drop from the normal operation, and therefore this engine has been flagged as something going on or something being irregular. And that's the easiest way that we find many of the test engineers are using, or quality engineers using us to find anomalies that are fairly complex in some cases. I would switch to a slightly different data set to show you a correlated search when we want to find a pattern between two measures that potentially can show exceptions. These are thermal power generators, and we have fans, and they have a pattern in the library defined. This is a correlated pattern, and I'll explain it. And notice here, this data is about 2 years of minute-by-minute data on a single turbine. And notice how little of the data we can fit on the graph. But essentially, this search and this query for a different pattern would go everywhere. So what the pattern means here is that you're seeing a jittery pattern in the red lines, in one of the fans, that's followed by a very big spike in the other fan, and that leads to faulty operations. And so we're looking in this case not for anything different, but we're looking for the exact match or a match within parameters. So we want to find a match that's 90% different, or expressed in cutting off points that's 90% similar. And so we're going to search for it, and we define it, bring us the top results that you match, and we'll look at the cutoff point. So we are running through a tremendous volume of data on a minute-by-minute basis. We're taking and breaking it into 106 minutes, the entire data set, traversing every one of them and finding these correlations. What I'm going to do now is I'm going to see here is a match that is nearly 100%, very close on the 4th digit. And you can see that we don't have a second match that's within the 90% limit that we had. So we want to go to that match, that very first match, zoom on it, and then bring the production variable. And as you can see, there is a lot of metrics in this system so that we can see what's happening in the real production process. And as you can see, right after the pattern, there is a significant slow in that production process, which somebody had to interfere to bring down. So again, here we're emphasizing the ability of searching for a correlated pattern. It can be 3, 4, 5 measures that are correlated. The correlations don't need to occur simultaneously. They may be offset in time. Some may occur earlier, some may occur later on it. And we're able to define cutoff points so that you can find patterns that are within certain limits so that you can eliminate any false positives on the pattern. And the third demo that I wanted to show comes actually from a transactional database. This is an Expedia sales of bookings, Expedia. And the question there is, and I'll show two very interesting functions here. The first one being that this is an aggregate data. All the transactions across all properties. And what most people are interested in is to find these spikes and pull them on a property level, on a site level, because they can be indication of good sales or they can be indication of fraud. And so let's pick up this pattern here. You see it now. I selected it right here. And what I'm interested in, this is kind of anomalous purchasing, but I need to have the stable pattern before the anomaly occurred so that I can benchmark and find patterns that have an anomaly. So I need to benchmark mathematically against the normal. And the challenge here is the following, is notice what happens if I introduce the product ID as a dimension. So suddenly we're going to 92,000 properties that are being sold through different sites. And if I add also the store, the website through which Expedia sells, it sells through multiple sites in multiple countries. Now I'm looking at over 940,000 time series. So the challenge here is to pull out of these instantly what that type of patterns. So let's get the algorithm again set to it, the right one for this data, and let's run it. So what I'm doing here, I'm running 900,000 queries simultaneously, and each one of these 900,000 queries goes through a year of transactional history to find the top patterns that match this type of pattern. So I'm going to switch now to a matrix view to visualize my my matches. And as you can see them here, they're fairly close. They're within the bounds of what is happening here in the pattern. And the one thing I wanted to emphasize, that patterns in real life are never identical. They're never 100% the same. This is why the complex math comes into place. So we can accommodate and say that these two patterns are mathematically the same, even though this one has a bump here and this one has a bump here. And that becomes extremely important when we're dealing with very, very large data set. And as a matter of fact, we were talking yesterday with the manufacturers that that's probably the biggest problem for them, is to be able to pull that information out of, some factories have anywhere between 10,000 and 1 million sensors. And being able to pull it out of that, like we showed here, out of nearly a million one, is a scalability really accomplishment. So with this, we're done with the demos. And Jeff, I hand it back to you.
Okay, excellent. Thank you very much. So if you have a question, and please ask questions. We really want to have this dialogue and this engagement with you in this time. You've invested some time to come in here and watch this webinar with us. So please ask some questions. If you have a question, type that into the chat. I'll call on you. We'll unmute you and you can ask us the question. I was thinking about doing it myself before, but let us know what you have, because we're only at 12:32 right now. We're definitely within the time that we set. So
we promise to be short.
Exactly. So please, if you have anything, type it in the chat and let me call on you, and you can ask your question. Meantime, while people are thinking through this, Yoshiko, there were a couple questions when we did our walkthrough the other day that maybe you can answer about architecture and cloud-based. There are some things that I know you have a lot of good background and knowledge on. Is there anything you might want to say right now?
Sure. So I think Rad already mentioned during the demo, but our solution is available on Microsoft Azure, Google, AWS. We have also done on Oracle Cloud. So it is available on any cloud platforms. And if you do require a solution on premise, it runs on any type of Linux OS.
Great. Thank you for that. Questions, please don't be shy. You just saw a lot of good stuff. We'd really love to start and open up a conversation with you right now. I'll give it a couple more minutes, and if no questions, then we'll close out and we'll give you the time back for today. So let's just give it a couple of more minutes. I want to thank Jeff Sward for being here today. Jeff is one of our consultants. We've been working with him on some retail data, and have so far been able to do some very cool stuff around retail. So that, I think, kind of, again, gives you a really good indication of all the different types of data that can be looked at and analyzed and acted upon within Trendalyze. Because, you know, if you can't act on what you have, you're nowhere. And that goes both ways. That's either to saving money or figuring out a way to monetize and to create some revenue out of what it is that you've got. All right, so it looks like we've got no questions. So I guess we can close out. Rado, anything else you'd like to say before we close out and say goodbye to everyone?
I want to thank everyone, and I want to say that don't hesitate if you have questions. Time series data is new, it's valuable, it's easily monetizable, so don't hesitate to take us up on our offer or to send us any questions that might help you move forward with your time series data initiatives.
Yep, please let us know if there's anything you need. All right. So thank you very much, everyone. We will close this out. Everybody have a great afternoon, and hopefully we'll see you at some time in the future. Bye now.